Alright, let's go. So before this kita stop some tanya for this 2B1Q, okay, 2 bits by line coding and one quaternary. So actually this one is bukan 21 tau. It's -1 and -3. I'm not jadi 2 and the next so it's just an F. So you all boleh baca lah So basically for this one dia ada rules dia yang tersendiri lah, okay. So for 0, 0 it's actually -3, okay, and then 1, 1 is +1, right, and 0, 1 is -1, okay. For 1, 0 is +3, +3, and then 0, 1 is same as this one lah, right, -1. So that's how lah, right. So for today kita akan continue with block coding. Okay. Block coding is still under data transmission, right? So what is the function of block coding? It is to improve the performance of line coding. Okay. Need some kind of redundancy to ensure synchronization. Okay. Need to include other redundant bits to detect errors. Right. So usually for block coding we use MB, NB punya block lah, right? So usually N, this one, N is bigger than M. Okay, kita tengok. Right, so for steps in transformation, okay. Okay, step 1 is division. Sequence of bits is divided into groups of M bits. Right, this is M bits, the first one, okay. And then step 2 is the substitution. Okay, so dia akan substitute M bit for an N bit group. Okay, for this case 4B/5B. Okay, 4 bits turns into 5 bits encoding. Alright, and then step 3 kita akan ada line coding. Okay, use one of the line coding schemes to create a signal. Okay, sometimes step 2 and step 3 can be combined. Okay, these both step can be combined. So kita tengok macam mana. So this is 4 bits block. Okay, kita tengok kat sini 0, 0, 0, 0. So 4 bit. So kita akan tukar into 5 bit punya block. Alright. So usually 4B, 5B punya blocks ni kita guna dengan non-return to zero invert lah. Okay, NRZI. Right. So NRZI ni usually dia ada sync problem. Okay, which it tends to have long sequence of zeros. Right. So kenapa, apa masalah bila ada long sequence of zero ni? Okay, so dia akan buat receiver punya clock lost its sync lah, okay, synchronization, right? Okay, so 4B, 5B punya block coding ni dia takkan ada consecutive more than 3 zeros lah, right? Kalau you perasan this one 2 je and then this one tak ada, just 1 0, right? So this is the data sheet lah for 4B and 5B. 4 bits slash 5 bits punya block coding. Okay. So for 000 punya data, 4 bits, it will turn into 11110 punya code. Okay. So you tengok kalau sini ada 3 consecutive zeros. So for 5 bits, you can ada just 2 lah maximum. Okay. Alright. So okay, so 4 bits ni dia akan produce 16 combinations. Okay, 16 combinations tu maksud dia apa? Yang ni lah, 0000001 0010, okay. So dalam 4 bits ni boleh produce 16 combinations. Alright, meanwhile for 5 bits punya combinations akan dapat 32 combinations. Alright, so since 4 bits ni dapat 16 combinations, meanwhile 5 bits ada 32 combinations. So akan for 5 bits ni akan ada lebih 16 more lah. Okay, 16 more tu some of it, half of it actually akan guna untuk this one. Okay, for control purpose. And then the rest, the other lebihan-lebihan tu tak digunalah untuk 5 bits. Alright. So then kita ada juga 8 bits, 10 bits. Okay. MB and B. So N is bigger than M. Alright. Similar to 4B 5 bits. Okay. Tapi dia punya 8 bits substitute into 10 bit code. Alright, sama je. Okay, so function dia is more error detection lah than 4B, 5B punya block coding. Alright. Okay, so this one is 8B 60. What is it? So substitute an 8-bit group with a 6 symbol code. Okay. Each symbol is ternary, having one of 3 signal levels. Okay. Each block of 8-bit data is encoded as a unit of ternary signal, 3 levels. Alright. So usually untuk 8B60 ni dia use for 100 base 40 cable lah. Okay. And then this number actually dia akan turn represented as a 2-digit hexadecimal number. You ada belajar ke pasal hexadecimal number ni? Kalau tak ada, you boleh tengok lah. Dekat, you boleh google je, actually ada dia punya calculator. Right? So to represent these 6 codes, actually kita ada lookup table lah. Tu pun ada dekat online, kat Google, you boleh google je. Okay. So for this one, kita kena tukar into hexadecimal dulu. Okay. And then baru boleh tukar to these 6 symbols. Alright. And then kita move to analog to digital modulation. This is still under digital transmission lah. Okay, tadi yang line coding, block coding tu adalah digital to digital modulation, right? And then this is analog to digital modulation. So kita ada PAM, PCM, okay, sampling rate, kita guna Niki's theorem, okay. How many bits per sample and then bit rate. So sampling. Line coding and block coding used to convert binary data into digital signal. Okay, from 00101 tu, you all akan convert to digital signal, which is yang kita buat block, like what is positive and then 0 and then -1. Okay, so voice or video created as analog signal. Okay, in order to store the recording in the computer or send it digitalized, needs to be changed through process of sampling, right? So this is pulse amplitude modulation. Okay, it is analog to digital conversion method. Okay, it's one of the method lah to convert analog to digital signal. Alright. So the technique is take analog signal, okay, sample it, generate the series of pulse based on the result of the sampling. Okay. Then sampling means measuring the amplitude of the signal at equal interval. Right? So this is, we call it as sample and hold. Right? So PAM has some application, but it is not used in data communication. However, it is the first step in another popular conversion method called pulse code modulation. Alright? So actually for sampling ni kita ada a few lah. actually three lah, three methods. Okay, so ada ideal, ada natural and ada top of analog signal. Okay, flat top analog signal. So dekat Google Classroom I ada upload textbook lah. It's 5th edition. Akan sebenarnya ada a newer version lah. A newer edition. Yang tu kalau you nak baca yang tu you boleh cari sendirilah. Alright, the 6th edition. But this one is the one I uploaded is edition. Ya.
Ada orang tak dapat masuk daripada link mana?
Itulah I cakap ada start kan pukul apa? 4:10 kan. Alright, so this is it lah. Okay, ni analog signal. So you want to change it into PM signal. Okay, the first one before you change it into digital signal, right? So analog signal, PM signal. This is sampling lah, basically sampling, right? Sampling ada 3 methods tu. Okay, ideal, natural and flat top. So if you want to know more, you can refer to textbook lah yang I've uploaded in the Google Classroom, right? So PCM, pulse code modulation. So it modifies the pulses created by PAM to create a completely digital signal. Okay, it's called quantization. Okay, method of assigning integral values in a specific range to sample instances. Okay, so this is analog signal, and then you turn it into, you sample it, okay, to PM signal, okay. So notice here tak ada value apa-apa lagi alright. And then dekat quantization, kat sini kita akan assign integral value lah, okay. So ni sebenarnya bukan 1 to 4 tau, it's positive, 1 refer to positive, I'm not sure why. Dia bertukar jadi 1 and then 2 is for negative, alright. Kalau you tengok memang betul lah 15, negative 15, alright. So from this, kita akan tukar to digital signal into bit streams, alright. Ni satu-satu ni kita akan tukar into bit streams. Lagi yang nak masuk. Okay, so this is the table lah. Okay, untuk positive 24, dia akan turn into this bit stream, okay. Positive 38 akan jadi macam ni, alright. This figure illustrates a simple method of assigning sign and magnitude to quantized sample, okay. Each value translate into 7-bit binary equivalent. The 8-bit indicates the sign. Okay, this bit. Okay, 0 is for positive and 1 is negative. Tengok kat sini lah. So 1 is negative lah. Betul lah ni dia punya value, integral value. Right. So and then what's next is you turn it into line coding. Okay. PCM is made up of PAM, quantization, binary encoding yang tadi tu. This one, binary coding. And then encoded into unipolar signal. Unipolar signal yang kita buat dekat line coding tu, yang the first one. Yang dia ada value 0 and positive je. Okay. Boleh refer yang tu lah. So this one kita encoded only this lah, this first 3. Okay. Plus 24 plus 38 plus 48. Ni lah. Right. Bila ada 1 for unipolar, macam kita belajar, 1 is positive, right? So this is basically it lah, the summary of analog signal to digital code. Okay, so from analog data masuk untuk PAM, or sampling. Alright. So dapat sample analog data yang tak ada value lagi, and then kita quantize it, and then akan dapat integer value. And then kita akan pergi ke proses binary encoding, which is yang ada dalam table tu. Okay. Then dapat binary data. And then go through process of line coding, which is unipolar encoding, right? So dapatlah digital signal. Okay. So this is a sampling rate, Niki's theorem. Okay. According to Niki's theorem, the sampling rate must be at least 2 times of the highest frequency. Okay, so kita tengok dari sini. The highest frequency is 5 lah. Okay. 5 times 2 times samples. Alright. So nanti kita akan tengok contoh. Okay, for this one. What sampling rate is needed for a signal with a bandwidth of 10,000 Hz? So macam mana nak kira sampling rate? Sampling rate must be at least 2 times the highest frequency. So kat sini, within this range, okay, what is the highest frequency? So 11. 1.1k kilohertz lah, okay. Alright, so the sampling rate must be twice the highest frequency in the signal. Okay, sampling rate equals to 2 times 11,000. Okay, 11,000 Hz. Okay, and then equals to 22,000 samples. Right. So yang ni basically ada masuk test rasanya. So you kena memorize sikit lah. Not that complicated pun. Okay, so sampling rate 2 times then its highest frequency. Right. Okay, a signal is sampled. Each sample requires at least 12 levels of precision. Okay. +0 to +5 and then -0 to -5. How many bits should be sent for each sample? Ada orang boleh jawab ke? So basically ni kan dia ada amplitude punya vertical line and then frequency of the signal lah kan. Okay. So from 0 dia punya maximum power volt dia adalah 5 +5. And then minimum power dia adalah -5. So from 0 to 10 to +5 and then back to -5 is 10 level. Alright. So dekat sini dia kata each sample requires at least 12 levels of precision. Okay, how many bits should be sent for each sample? Okay, how many bits? Alright. So jawapan dia we need 4 bits. Okay, 1 bit for the sign and 3 bits for the value. Okay, a 3 bit value can represent 2 power of 3 dapat 8 level saja. Okay. Ini sebenarnya apa ni? 3 bit, 4 bits. Okay, contoh kalau 3 bits 0, 0, 0 and then 0, 0, 1, 0, 1, 0. Okay, you akan dapat digits tu akan dapat the combination yang tak akan berulang, akan dapat 8 levels dia, right? So kalau 4 bits 2 to the power of 4 akan dapat apa? Dapat 16 lah kan? Okay, kalau 2 to the power of 3 dapat 8 levels, dah cukup. Dia cakap at least 12 levels. Alright. And then nampak ni 0 to 111. The combination of 3 bits ni. Alright. And then a 2 bit value is not enough since 2 to the power of 2 is only 4. Dapat 4 levels je. Okay, kalau 2 bits, the combinations tu akan dapat 4 je. Alright. So 4 bits value akan dapat 16. So apa? Cukuplah untuk 12 levels tu. Right? Okay. And then move on to bit rate. Okay, after finding the number of bits per sample, we can calculate the bit rate using the following formula. Okay, sampling rate times number of bits per sample. Alright. Tadi sampling rate macam mana? Sampling rate must be twice highest frequency. Right? We want to digitize the human voice. What is the bit rate assuming 8 bits per sample? So the solution, the human voice normally contains frequencies from 0. Okay, so dapat 1000 samples. And then to calculate bit rate pula, sampling rate times number of bits per sample. So tadi dia nak assuming 8 bits per sample. So times je lah. Okay. 8000 times 8 equals to 64 bits per second. So you convert lah into kilobits. Okay. So this conversion ni basically dulu sekolah rendah pun dah belajar. Nano to micro. Okay. Alright. So note that we can always change a band pass signal to a low pass signal before sampling. Okay. In this case, the sampling rate is twice the bandwidth. Alright, so this is analog transmission. Okay. The first one is digital to analog modulation or conversion. Kita nak convert digital signal into analog signal. Right, so kita akan guna these four methods lah. Okay, akan ada amplitude shift keying, frequency shift keying, phase shift keying and quadrature amplitude modulation. Alright, from digital signal, okay, and then masuk digital analog modulation, right, and then turns to analog signal. Right, so ada techniques. This one lah, okay, ASK, FSK, PSK, QAM. This is a technique, okay. So ada ASK amplitude, F frequency, P is phase, and then ada QAM is combination of ASK and PSK. Alright. So this is from digital signal. Okay, kita nak turn into analog signal. Okay, this is amplitude. Amplitude yang berbeza, right? And then B, what is this? This is for frequency and then this is for phase. Right? Tengok satu-satu lah. Okay, so a little terminology. Okay, bit rate is the number of bits per second. Okay, baud rate is the number of signal units per second. Baud rate is less than or equal to bit rate. Okay, so baud rate must be less than or equal to bit rate. Okay, for example, an analog signal carries 4 bits in each signal unit. If 1000 signal units are sent per second, find the baud rate and the bit rate. Right? So baud rate dia, baud rate is 1000 baud per second. Okay. So how to find the bit rate? 1000 times 4 bits. Alright. Close to 4000 bits per second. Okay, and then we have another example here. The bit rate signal is 3000. If each signal unit carries 6 bits, what is the baud rate? Okay, so this is the formulation. Okay, how to calculate baud rate? Okay, so bit rate divide by number of bits per signal unit. Okay, so bit rate is 3000. Number of bits is 6 bits. So 3000 divided by 6 equals to 500 baud second. Right. And then in analog transmission, the sending device produces a higher frequency signal that acts as a basis for the information signal. Okay. The base signal is called a carrier signal or carrier frequency. The receiving device is tuned to the frequency of the carrier signal that it expects from the sender, and then digital information then modulates the carrier signal by modifying one or more of its characteristic, okay, either amplitude, frequency or phase. This is basically the characteristic for sine wave lah. What is sine wave? Sine wave is this one. Bentuk dia macam ni. A simple wave, alright. So dalam textbook ada, you all boleh refer. Okay, so the touch on the first technique for digital to analog conversion. Okay, amplitude shift keying. Okay, amplitude changing while frequency and phase remains constant. Okay, amplitude. Apa amplitude this one? Okay, amplitude dia berubah. Kalau you tengok kat sini, dia rendah sikit. Kat sini dia akan tinggi. Amplitude berubah lah. Okay, so for example, this one is 1 volt and then this is 2 volt. Alright. So amplitude shift keying. The amplitude is changing. Alright. So the strength of the carrier signal is varied to represent 1 or 0. Alright. The strength. So kalau you tengok kalau sini 0, dia a bit weak lah. Okay. The signal. And then kalau 1, dia lagi tinggi lah. Okay. Dia punya strength. Alright. The presence of a carrier wave to indicate a binary 1 and its absence to indicate a binary 0. Alright. A popular ASK technique called on-off keying. Okay, for example, it is used at radio frequency to transmit Morse code. Right. So the drawback of amplitude shift keying is highly susceptible. Apa maksud dia? Apa tahu? To noise interference. Okay. So it refers to unintentional voltage probably affected by heat or electromagnetic induction created by other source. So dia kan ada noise lah. Alright, noise interference. Yang ni pun kita akan touch dekat maybe next chapter or you can just read it from the textbook lah. Okay. So the advantage of the amplitude shift keying is reduction in the amount of energy required to transmit information. Alright. Why reduction of amount of energy? Sebab kat sini kalau 0 dia guna lesser energy. Okay. So for 1, dia guna a bit more lah. Alright. And then frequency shift keying. So you tengok, what is frequency? Frequency ni 1, 2. Okay, frequency. Bagi. Dia cukup one cycle. One cycle of wave ni, it's a frequency. Alright. So in frequency shift keying, the frequency of the carrier signal is varied to represent binary 0 and 1. Okay. So for 0, dia less frequency, but for 1, for bit 1, it has more lah. Alright. Okay, FSK is not. Okay, peak amplitude and phase remain constant. Okay, peak amplitude ni. So you tengok dia selari je, dia tak berubah macam tadi. Macam tadi kat sini dia rendah and then kat sini dia tinggi sikit kan. Alright. So FSK not affected by noise because receiving device focus on the specific frequency change over a number of period and ignore voltage. Okay. The common FSK is binary frequency shift keying, BPSK. Right. And then the last one is phase. It's not the last one lah. Actually akan ada satu lagi combination of this one and another one. Okay. Phase shift keying. Alright. So phase tu apa phase? Phase is the position of waveform relative to time zero. This is phase. Dia punya apa degree, actually it's a degree. Right? Dekat textbook ada, you boleh refer. Dia ada 0 degree and then 90 degree, 180, and 360 degree and then so on lah. Right? Okay, in phase, okay, kalau you tengok kat sini, maksud dia apa? Kan dia tadi direction kan? Maksud dia untuk phase ni direction. Yang kat sini dia bertukar kat sini. Kalau tadi dia punya phase sama je, sambung semua sama. But then this one phase dia berubah. Alright? Dia akan jadi macam M lah, jadi macam W lah. Alright? So both peak amplitude and frequency remains constant. Okay? Amplitude and frequency sama je. Alright? While the phase tend to change. Okay, if the phase begins with 0, it will represent binary 0. Okay, then it can change to binary 1 by beginning with phase 180. 80 degree. Bila kat sini from binary 0, okay, dia akan start dengan 0 degree. This is 0 degree. Alright. And then bila by binary 1, dia akan shift to 180 degree. So kalau kat sini 0, akan jadi macam mana? Dia punya form.
Di atas.
Betul. Macam tu lah. Right? Okay, the common technique is 2 PSK and binary PSK. Okay. Use 2 different phase. Okay. Ini pun tak tak susceptible to noise degradation. Right? That affects ASK amplitude, shift keying or bandwidth limitations of frequency shift keying. Okay. This is quadrature PSK or 4 PSK. Okay. Untuk phase kita akan ada teknik lah. Okay. To PSK and binary PSK. Okay, get more apa function ni? Quadrature PSK ni, okay. Get more efficient use if each signal element represents more than 1 bit. Okay, so for example, shift of pi by 2 is 90 degree, okay. Each element represents 2 bits, okay. Split input data stream into 2 or n modulated into carrier phase shifted carrier, okay. Can use 8 phase angles and more than 1 amplitude. Okay, for example, this one is 9600 bit per second modem, uses 12 angles, 4 of which have 2 amplitudes. Okay, so this is quadrature PSK lah. Kan ada 2 bits kan untuk satu board. Okay, so dia punya table macam ni. Kalau 00 is 00, okay ni dia punya quadrature constellation diagram. Yang ni pun you kena fokus jugalah sebab ni biasa ada keluar test, right? So kalau 00 dia punya degree is start dari sini kan, 0 degree. And then kalau 01, 90 degree. So kalau you tengok kat sini memang betul lah, okay, 90 degree, alright. And then for 10 is 180 degree. 180 degree, alright. So for 11 is 270. Macam ni, 1, 2, 3, 4, alright. Okay. Okay, 4 variations and each phase shift represent 2 bits. Alright, a pair of bits represented by each phase bit. Okay, more efficient because able to transmit data twice twice the data. Right, tadi quadrature 4. Sekarang kita move to 8. So phase dia akan ada this lah. Alright. So akan increase by 45 degrees. Okay, so for 0, 0, 0 yang tadi debate to apa? To bits. To binary bits, okay. And then this one is 3 bit. Right, akan ada 3 bits, right? So for 0, for phase 0 is this one. 0 degree. Okay, and then 0, 0, 1. Akan tambah 45 degree. Okay, kalau you tengok kat sini 45 degree lah. So kalau 0, 1, 0 is 90 degree, right? And so on. Okay, this is quadrature amplitude modulation. It is combination of amplitude shifting and phase shifting, right? QAM used on a symmetric digital subscriber line, ADSL, okay. It's the logical extension of QPSK, okay. Quadrature, phase shifting, okay. Logical extension, okay. Send two different signals simultaneously on same carrier frequency, okay. Use 2 copies of carrier, 1 shifter, 90 degree. Each carrier is ASK modulated. 2 independent signal over the same medium and emulated and combined for original binary output. Tengok dia punya figure macam mana, okay. QAM is combination of ASK and PSK so that a maximum contrast between each signal unit, bit, debit, 3 bit and so on is achieved. Okay, ni kalau you tengok 1 amplitude. Amplitude tu yang tu lah. Yang 1 volt ke 2 volt ke, okay. This one is amplitude, right. 4 phase, okay. 4 phase. Satu phase 1, 0, 0. And then ada 90, 180 and 270, right. Okay, the number of amplitude shift, this one is the number of phase less than the number of phase shift. Okay, kalau yang ni boleh tengok ada 2 amplitude. Okay, ni nampak tak? Dia akan ada 2 level. Alright, akan ada 4 phases. Sama juga 4 phase. Dia punya phase from 0 degree to 90 degree, 180 and 270 degree. Right. So that is it. So basically sebenarnya dia ada satu lagi term, analog to analog modulation. Nanti you boleh refer textbook lah. Okay. For this slide, kita cover sampai digital to analog transmission. Conversion saja. Okay, modulation. So kalau dekat analog tu ada AM, amplitude punya modulation, frequency punya modulation and then phase modulation. Akan ada 3. Alright. So dekat Google Classroom, saya ada upload tutorial 2. Okay, you bolehlah buat exercises. Untuk macam contoh untuk ni, dia dah bagi apa bit stream, you convert into this encoding lah, right? Yang ni macam famous juga masuk dalam test. Okay. You hafal lah contoh kalau kan ada 3 kan, line coding ada apa? Ni line coding ada unipolar, polar, bipolar. Okay, so unipolar ni satu je lah. Polar ada 4. Apa? NRZ, RZ dengan Manchester. Okay, NRZ tu ada 2 pula. Invert dengan level. Alright, Manchester akan ada satu lagi, Manchester invert . Differential Manchester encoding. Alright. Kan ada 4 polar, alright. Then ada bipolar is AMI. Yang kita guna AMI lah untuk bipolar, right? This is ada scheme lah untuk line coding. B1Q, MLT3. Okay, and then kita ada block coding. Atau data modulation. Kan ada ni sampling. Right. Kita tak ada calculation yang kompleks. Tapi kita ada yang simple calculation lah. Contohnya macam ni lah exercise ni. Kalau you tengok dekat dalam textbook tu dia lagi kompleks lah. Guna-guna scientific calculator and stuff. Right? So that's it for today. Sekejap bagi attendance. Hamzah ada Hamzah?
Saya doktor.
Dah sihat?
Baik dah. Tinggal batuk-batuk je.
Oh. Besok saya ada lab dengan group C. Kalau you nak join boleh lah nak buat cabling.
Oh, okey doktor. Pukul berapa doktor?
Pukul 12. And then besok ada tutorial dengan group A kan. Besok kita buat lab tu lah. Right, bawa laptop. Kalau ada extension wire pun bawa lah. So kita guna bilik tutorial je. Okay. So untuk tutorial dalam Google Classroom tu you bolehlah buat untuk sebagai latihan. Okay. Boleh refer textbook untuk dapatkan jawapan. Kalau nak tanya apa-apa boleh tanya je. Alright. So is attendance. So next chapter kita akan cover multiplexing. Okay. I dah upload dah pun. Slides tu bolehlah baca dulu ke apa pun. Okay, contohlah dalam ni kelas ni kan, dalam lecture ni you tak faham, ada benda you tak faham ke, you can always refer to textbook. Okay. Sebab you dah degree ni tak adalah nak kena spoon feed semua kan. Dah besar, you boleh explore sendiri. Dan you ada kawan-kawan boleh bincang juga. Dan Google tu paling banyak maklumat. Alright. So untuk formal punya reference is the textbook lah. Right. So informal punya reference you can watch YouTube videos. Okay. Baca artikel ke. Right. So you all ada SLT kan? Self learning time. Kenalah ikut. So for one day kena spend berapa jam untuk belajar sendiri. Okay. Boleh buat tutorial ke. Ada yang dah pernah guna ni tak? Packet tracer? Group apa? Ada yang dah install?
Dah.
Belum.
Group C belum?
Belum.
Group C belum lagi.
Group A dengan B dah kan? Tak apalah, nanti kita register. Habis tu group A dengan B dah pandai lah kan guna packet tracer ni?
Tak pandai lagi.
Tak pandai.
Habis tu yang belajar sebelum ni?
Belajar yang basic-basic je.
Basic sebab you kena guna ni tau. Untuk assignment, untuk lab 8 nanti kena guna packet tracer tu. Silalah explore. Untuk group C nanti kita register dulu. $68 baru ni. 10 orang. 9.
Madam, esok kelas C kat mana ya?
Kat Makmah 17.
Alright.
So that's it lah for today, right? Thank you class. Jumpa.
Thank you, madam.
Right.
Thank you, madam.
Madam.
Thank you, madam.
Madam.
Thank you, madam.
Thank you, madam.